recording a video thinking that you are golden just to figure out that you're out of frame the entire time is the worst possible feeling. And of course, having a camera person would be ideal, but I don't got the bread to drop on that. So instead of going broke, I decided to make a cameraman myself. Say hello to my new robot cameraman, Snapmaster Flex. So if you're a camera person, drop your prices or this robot will take your job. Ain't that right? Alright, so robot cameraman, $1 million idea, but how are we gonna do it? I first wanna focus on the movement. So the plan is to use 2 servo motors, one to control the pan and the rotation, the other one to control the tilt. And if you don't know what servo motors are, they're like little DC motors with a gearbox attached to them. So with the gearbox and the help of some internal electronics, we can set the motor to a precise angle. And this precision is super important because we need the camera to be as precise as possible when it's tracking my face to make sure I'm always centered in frame. And now you're probably wondering, how is it gonna track my face in the first place? And it's easy. I'm using some artificial intelligence. And yes, I know artificial intelligence has been all the rave recently and nobody really even knows what it is for the most part. But don't worry, I can break it down for you. So all artificial intelligence is giving computers the ability to think like the same way humans do. An example of this is, of course, ChatGPT. You input some type of data, which is a question, it thinks and processes it, and then it gives you some type of answer. Now, if that input data you give the computer is a picture or a video, it gets into the field of AI that we're working in, which is computer vision. But you can't just feed it a picture and think everything is good, because the robot is not gonna know what it's looking at. So, in order to teach the AI what that picture is, we're gonna use machine learning, which basically means we're just gonna train it. We trained it by putting a bounding box over the object we want to detect and telling it that thing I boxed is a person. If you see anything else that looks like it, it also is a person. And of course, just like teaching any person something, the more you do it, the better it gets. Originally, I tried making my own model and only trained it using 100 photos, and it wasn't the best just because 100 photos is not nearly enough images to train a reliable machine learning model. So for the sake of testing, we're gonna use a pre-trained model, and then if everything goes well, we could dive into the thick of it and train our own. So lastly, let's go over the design. So first we have our pan servo, which is attached to the top of the electrical box. It could turn a total of 180 degrees. Next, we have our tilt servo, which is gonna be able to move forward and back. And this little slot is gonna go our webcam, and that's what's gonna be tracking our face. And because my main camera is my phone, I added a cold shoe mount right here, so I can attach my phone to it. So now I'm gonna print out everything, lay it all out, and put it all together. All right, so everything is put together, and honestly, he is looking pretty good. My boy Snapmaster Flex. So my boy is all set and ready to go. So I hooked him up to the tripod, and now it's time to start testing him. So I'm not gonna lie, I got the prototype set up way faster than I expected, but you know what they say, the first 80% of the work only takes 20% of the time, and the last 20% of the work takes 80% of the time. So with that said, let's talk about what we need to fix. So the very first problem I'm having is just the model isn't as accurate and precise as I want it to be. First of all, it doesn't track me if my face is just a little bit rotated or if it's a little bit sideways, which isn't good. If I turn sideways to look around, I still want the camera to track my face. And also if I move too abruptly or move too fast, the camera just completely loses track of me and it tries to keep up towards the end. I think that's a problem as far as like just our hardware isn't as fast as we need it to be because we're only using a Raspberry Pi, so we might need to upgrade that in the future. Also, the last problem is just the overall movement. The movement is very sharp, very abrupt. The servo motors just try to snap to my face immediately. And if I do have my camera set up on this thing, that is not gonna make for great footage at all. So now that we know what we need to fix, let's get back to the drawing board. Okay, so the first thing I wanna fix is the movement. But before I explain to you how I'm gonna do that, first let me explain to you how the camera works. Every time the camera detects a face, it gets the exact center of it using some math. It then calculates the difference between the center of the face and the center of the actual frame. Then it sees that difference and it tells the servo, okay, this is how many pixels you need to move the camera so that the face is center and the center of frame matches up. But the way we're giving that information to the servos is we're just feeding it in there, and we feed that information in there, the servo just tries to move immediately without any breaks to that position. So to fix that, we're gonna use something called servo easing. And servo easing is just a set of multiple different types of functions in order to not change values as fast. And I don't want to really get into the math of it. Just know it works, and here's the difference between servo easing and no servo
we're using.
The second thing that we want to fix is upgrading the model, to be honest. The current model we're using is called Hard Cascade, which is usually only used for detecting really specific objects that are not going to change in size and that's going to be in a super specific environment. So we're going to use a different model called SSD, or single shot detection. A slightly newer machine learning model, but it's like insanely accurate and it's super fast because it only needs to see the image one time. But as I said before, the Raspberry Pi was maxed out as far as processing power. So we're gonna upgrade it to this beast, which is a Jetson Nano. And doing both of these two things should also fix the problem that we was having with the camera just completely losing track of our face if we move too fast. So before we actually test the final product, I went ahead and bought a robot cameraman, quote unquote, that you could buy online. And I really want to see how good it is compared to the one that I went ahead and built myself. So I ordered that, and once that comes in, we're gonna go ahead and test it. And don't forget, if you're liking the video, make sure to give me a like. And if you want to see more of the cool stuff I build, make sure you subscribe to the channel. Package just came in. All right, so I'm about to set it up, see the facts on it, see if it's gonna do what we needed to do. All right, so as you can see, we have this thing set up. I'm not gonna lie. I'm not gonna lie. It is kind of wavy. Like, it's kind of lit. Like, it has zoom in, so when I walk towards it, it kind of zooms in, but when I walk back, it follows me. That's wavy. If I squat a little bit, pause, and to the left, and to the right, and to the left, and to the right. All right, so that camera was cool or whatever. Nah, I'm not gonna lie, it was pretty good. But it is time for the reigning, defending champ, Snapmaster Flex, to show you what he could do. So we got my boy set up, and look at him, moving crisp, smooth, movement is on point. I'm going right, left, he's not losing the track of me. He's not moving too slow, not moving too fast. Look at the tilt motion, everything is looking pretty good. So now we're gonna do the same thing, but we're gonna try it with my phone attached. All right, here we are. You see it? It says your boy Nas. So what I noticed already is low-key not as stable since the way the phone is on there, which could be fixed if I just did a better job balancing it. Boom, we here. Whoa, so you see the sideways? Sideways is picking me up. Sideways that picks me up. Now if I move a little fast, it stays on my face. It doesn't like lose track of it. And all the movements are super smooth compared to the first version. I really want to see how it looks on the phone. So overall, I'm honestly mad happy with the build. Comment below who you think won, my boy Snapmaster Flex or that other webcam I was using. But before you do that, there's one thing my boy Snapmaster Flex can do that the other camera can't, and that's dance.